So in this section we deal with something that is actually quite similar to permutations. We're now dealing with something called combinations. The only difference here is that in a combination, the order that the items are chosen does not matter. To put that in perspective, with a permutation, the order did matter. So with a permutation, we might be asking a question: in how many different ways can three runners finish first, second, and third in a race? It does matter who's first, who's second, or who's third. With a combination question, we might be asking how many ways can we choose a committee of people. It doesn't matter who gets chosen first, second, or third, as long as you get chosen. What that does is actually lessens the number of options, because now any way in which Bill, Joe, and Steve get chosen, they all count as the same. Likewise, we're talking about decks of cards, especially if we're dealing with a poker hand. It does not matter which order the cards get dealt to you, as long as you get them. So here we're dealing with 5 cards getting dealt. And in how many ways can we dealt a hand that has only red cards? We still need to ask ourselves the same questions as we did with permutations. How many items do we have in total to choose from? Well, we're choosing from only the red cards, so it's 26. How many items are we actually going to take out of that? That's 5. But with permutations, we used a P. Combinations, we're going to use a C. Now, the way we access this function is exactly the same spot as we would access the permutation function or the factorial function on the graphing calculator. We'll type in 26. We'll go to the math function, over to probability, and NCR is option 3. So 26, pick the NCR option, input a 5, and calculate that out, and we get that there's 65,780 different 5-card hands that consist of only red cards.